Hello students, how you doing? Well, exciting. Today we're starting a new chapter, and this chapter is the chapter about impulse and momentum. You've had studied impulse and momentum in O-level, but you're going to be studying that in Mechanics 1 in a little bit more depth, all right? So to begin with, I'm going to remind you with few things that supposedly you have learned in the past. What is momentum? Well, any mass that's moving has momentum. A mass that's moving has momentum, because momentum depends on two things. By the way, momentum in physics, we use letter P for what? For momentum, which is lowercase p, okay? Well, momentum is a vector quantity to begin with, and it's equals to the product of the mass and its velocity. All right? For that reason, the unit of momentum would be what? The mass has a unit of kilograms, and velocity has a unit of what? Meter per second. So the unit of momentum would be kilogram meters per second. Perfect. Well, in order for a mass to have high momentum, it's either that it has to have a large mass or a high velocity, or both together. So what increases momentum is either the mass or velocity or both together. So for example, a big huge truck could have the same momentum as a small mass, very small mass that's few grams, such as the bullet. The bullet has a very small mass, but it has a very large speed. So it could have the same momentum as a truck moving at a certain speed. So remember that momentum does not only depend on mass, but also on velocity, and it is a vector quantity, which means it has a magnitude and it also has a specified direction, which we should pay attention to when we solve problems on momentum. We have to pay attention to the direction. Perfect. Excuse me. Well, that is for momentum. Well, let's say that a mass of 2 kilograms is moving at a speed, initial speed of 5 meters per second. And all of a sudden, a force has acted on that mass, increasing its speed or velocity to 12 meters per second. Well, there is an increase in momentum, right? The momentum of the mass initially was, what's the momentum initially? Momentum was mu. And finally, momentum became mv. So if you do calculate the initial momentum, it's going to be 2 times 5, which is 10 kilograms meter per second. And the final momentum is 2 times 12, which is 24 kilogram meter per second. There is a increase in momentum. There is an increase in momentum. Let's just put the direction of the velocity over here. There is an increase in momentum. That increase in momentum, we can calculate it by what? By subtracting P1 from P2. And this is called change in momentum. What do we call this? Delta P means change in what? Change in momentum. Because the change in momentum could be positive. If it's positive, then it's an increase in momentum. If it is negative, then it's a decrease in momentum. Generally, it is called change in momentum. All right, so we know now what the change in momentum is. Well, now that we have learned what momentum is, I need to take you to the next slide, which is what is impulse. What is impulse? Impulse is when you give a push to the object, exerting a force on it. You give it a push, just a push. You just kick it or push it. Then you give it impulse. So with impulse, you can increase momentum or decrease it. How? If you apply a force in an object, if the object is moving initially in that direction, and you give it a force, you push it with a force, you give it a push, all right? Or you kick it with a force, then this velocity is going to increase. That's going to increase its momentum. So impulse, does that mean impulse is the force? Well, approximately, but not quite yet. Because if I want to increase the momentum from U, let's say that the mass is M, from U to V, right? If I want to increase, so it's the same mass, right? It is the same mass. Even though I have drawn it a little bigger, I need to just make it smaller. All right. All right. Now, by giving it that push or that kick, I have increased its momentum. So its momentum was mu, and now it is mv. I increase the momentum. If you apply a greater force, a larger force, then you're gonna obtain what? More what? It's gonna act, because force causes acceleration. So you're gonna get more velocity after what? Exerting the force. More velocity, which means you're gonna get what? More momentum. So the higher the force, the greater the force you exert, the more change of momentum you will have. Because change in momentum, which is what? Equals to mv minus mu, depends on what? Depends on two things. Number A, it depends on the force that has caused the acceleration, increasing the speed from U to V. And also, it depends on the time duration of the force. The time duration of the force means, am I going to apply the force for half a second? Am I going to apply the force for 1 second or for 2 seconds? See, the longer the time duration of the force, when you apply it onto the mass, the more speed it will gain, which means the more momentum it will gain, right? So that means impulse depends on what? The force and the time duration of the force. That's what impulse depends on. For that reason, impulse equals to force times time. The force you apply to change momentum and the time duration through which the force is applied. See, this is the time of application of the force. You apply the force for half a second, then you multiply what the force by half a second. You apply the force for 3 seconds, you multiply the force by 2 seconds to what? To determine or to calculate the impulse. So what's the unit of impulse? Impulse as a unit, impulse is measured in, well, let's see, what's the unit of force in Newton? What's the unit of time? Seconds. But keep in mind that kilogram meter per second and in Newton seconds, look, in Newton seconds, you know that in Newton is a force, right? Force. And force usually is what? Is MA, which means in Newton is, what's in Newton? Kilogram meter. In Newton is kilogram meter per second squared, because the mass has a unit of kilogram and the acceleration has a unit of meter per second squared. So Newton is kilogram meter per second squared times what? Second. Second cancels second, so you end up with what? Kilogram meter per second. I'm doing this just to tell you that Newton seconds is the same unit as kilogram meter per second, right? Is the same thing as kilogram meter per second. Because in Newton is what? Mass times acceleration, which is kilogram meter per second square, and time is second. When you multiply kilogram meter per second squared times second, you will obtain kilogram meter per second, which is the same unit as what? As momentum. So the unit of momentum, kilogram meter per second, the unit of impulse is in Newton seconds, and they are what? Actually the same unit. They are the same unit because they consist of what? Kilogram meter divided by what? Seconds, or per second. Well, impulse could increase momentum. Impulse could decrease momentum, because if you apply the force in the opposite direction of the motion, what are you going to do to the velocity? You're going to decrease it. For that reason, impulse could either increase or decrease momentum, depending on the on its direction. So if the impulse is applied in the same direction of the momentum, it will increase it. But if it's applied in the opposite direction of the momentum, it will decrease it. All right. Now, so far we have learned this. We have learned that impulse, which means the push which can be determined from what? From force times time. And the unit for impulse is what? In Newton second, which is the same thing as what? As the unit for momentum, which is kilogram meter per second. So impulse equals force times time. The push that you make to any object that's in motion or at rest is going to increase its momentum. So impulse is the reason behind increasing or decreasing momentum. So change in momentum, increasing or decreasing momentum means what? Change of momentum. Change of momentum depends on what? Depends on impulse. Change of momentum depends on impulse. There is a relationship between impulse and change in momentum, which I will address with you right now. So if I go to the next part here, says what's momentum impulse principle? Well, let me tell you what it is. Well, you guys know, for example, you know that acceleration, usually the force that you apply on an object that's moving to change its momentum, that force is going to cause the object to what? To accelerate. So we start from acceleration, right? The force, impulse can cause a mass to accelerate, so it increases its speed. For that reason, it will increase its momentum. If you do a cross product here, then you're going to get V or A times T equals V minus U, right? And now what I want from you is just to multiply both sides by M. If you multiply both sides by M, then you're going to get this. What's MA? F equals MA. So MA is force. Force times time equals M times V is MV, and M times U is MU. So that means F times T is impulse, and MV minus MU is what? Change in momentum. So that is the relationship between what? Impulse and momentum. Impulse equals change in momentum, which means impulse equals final momentum minus initial momentum. And that's called the momentum impulse principle. Remember that. Impulse equals what? Change in momentum. For that reason, for example, if the force is missing or the time is missing, from the change in momentum, you can calculate either the force or the time. Because if you solve this for the force being applied can be also obtained from mv minus mu over t. Similarly, the time duration of the force could also be calculated from mv minus mu over f. Remember that. But the bottom line, impulse equals change in momentum. Okay? The amount of the push, depending how large the push is, how strong the push is. Push means what? The push means impulse. Depending on how big the push is, which is the impulse is, whether it's large or small, if it's a big push, it's going to cause what? If it's a big push, this is the push or impulse. If it's a big push, then it's going to cause what? More increase or decrease in momentum, more change in momentum. See, the smaller that push, it will cause what? Less change in momentum. I mean, if you want to decrease the momentum, you apply an impulse in the opposite direction of the motion, which decelerates the object, okay, giving it less velocity, which means the final velocity will be less than the initial velocity, so that's going to cause a decrease in momentum. Perfect. After all of that, we deserve some practice. Well, let's see what we got here. It says, find the magnitude of the momentum of a cricket ball of mass 400 grams and speed or velocity of 18 meters per second. All right. Momentum equals to mv. So remember that the mass has to be in kilogram. So mass equals to 400 grams, but must be changed to kilogram. Never use, because the SI units are what? International standard units used are what? Kilogram for mass, meter for length or distance, and seconds for time. So whenever you see mass given in grams, you have to turn it to kilograms. Whenever you see distance given in centimeters, millimeters, or kilometers, you have to turn them back to what? To meters. Whenever that time is given in days or hours or minutes, you have to change them to what? To seconds. So in this case, momentum equals to, that's going to be 0.4 kilograms. 0.4 kilograms times 18. So that will be 7.2 kilograms meter per second. All right, a lorry of mass 5 tons. Remember that 1 ton equals to what? 1,000 what? Kilograms. So I have to change that to kilograms. All right, so a lorry has a mass of 5,000 kilograms because 1 ton is 1,000 kilograms. Is moving at a speed of 0.3 meter per second. Find the momentum of the lorry. So momentum equals mv. So it is equal to 5,000 times 0.3, and that will be 1,500 kilogram meter per second. All right, that's direct question with direct substitution of the values into the formula. We'll go to the next one now. What we got next? A body of mass 2 kilogram initially at rest. Well, that body has a mass of 2 kilograms. Initially at rest, initial velocity is 0 on a smooth horizontal plane. A horizontal force of magnitude 4.5 newtons is being applied onto the mass which was initially at rest. It was stationary. But the force was applied for how much time? That's the duration of time, for 6 seconds. That is going to allow us to calculate the impulse of that force, because impulse equals force times time. What's the magnitude of the impulse given to the body? Well, impulse equals to force times time, so equals to 4.5 Newton times 6 seconds. So that will be 4.5 times 6. 4.5 times 6 equals to 27. What's the unit of impulse? In Newton seconds, which is the same as kilogram meter per second. All right, what do we got next? I mean, what do we got on part B of the same question? We got the impulse of that force. The final speed. Well, I know that I have learned earlier that impulse equals change in momentum, right? And I have learned from the question that initial velocity was 0. So that's going to give me what? All of this equals to 0. Impulse was 27, and the mass is, I forgot what the mass is myself. The mass is what? 2 kilograms. 2 kilograms times v. So that means the final velocity will be what? 27 over 2, which is 13.5 meter per second. All right, that's straightforward. We found the final speed by using the relationship of impulse and change of momentum principle, right? The initial momentum was 0 because the mass or the body was at rest. So final momentum minus initial momentum is change in momentum equals to impulse. So that gives me 27 equals to 2v, and v equals to 13.5 meter per second. All right, what do we got next? Example 3. A ball of mass 0.2 kilograms. Very good. a ball of mass 2 kilograms, so 0.2 kilograms. So the mass is 0.2 kilograms. Hits a fixed, this is, see, hits a fixed vertical what? This is the ball, and it is what? 0.2 kilograms. It hits a vertical wall, this is a wall, all right, with a speed of 3.5 meters per second. So the speed is what? U equals to what? 3.5 meters per second. All right. Then find the magnitude of the impulse exerted on the wall by the ball. But it says that the ball rebounds. The ball rebounds with what speed? So this is the final velocity after collision. After it crashed into the wall, it rebounded with a speed of what? 2.5 meters per second. Now, if you guys can tell here that the speed direction has been reversed. It was towards the right before collision or crashing, and now it's towards the left after it has rebounded off the wall. So we know it's going to adopt these directions. Any velocity that's going towards the right is going to be considered a positive velocity. Any velocity going towards the left, it should be assigned a negative sign. Why? Because velocity is a vector quantity, so we have to distinguish between their directions using positive and negative signs. Simply because we are dealing with momentum and impulse and they are both vectors. So we should pay attention to the direction of the velocities. All right, find the magnitude of the impulse exerted on the wall by the ball. Well, let me tell you something. For any two, I'm just gonna get out of the question itself for just 1 second. If I have two objects colliding, this object is moving this way, this is mass 1, for example, and this is mass 2, right? And this is moving at speed of u1, this is moving at speed of u2. So speed of u1 is positive because it's going right, and the speed of u2 is negative because it's going left. Now, listen to this very, very carefully. This is going to give a push to this, and M2 is going to give a push to M1. Both going to give a push to each other. So the impulse exerted by M1 on M2 will be this way. That's the direction of the impulse on M2. And the impulse exerted by M2 on M1 should be in that direction. This is the direction of what? Impulse exerted by 1 on 2. This is the impulse exerted by 2 on what? On 1. But remember, this is complies with Newton's third law. For each action, there is an opposite and equal reaction, because impulse simply is what? It's a force times time, right? So in this case, impulse exerted by mass 1 onto mass 2 equals to impulse exerted by mass 2 into mass 1, but they are equal in magnitude, but they are opposite in direction. So always, since they have asked us for the impulse exerted on the wall by the ball, on the wall, so that means they need the impulse on the wall. Well, if I calculate the impulse on the ball, it's the same as the impulse on the wall because they are equal. But they have what? Two opposite directions. So they asked me for the impulse what? On the wall. I don't have speeds for the wall to calculate its change in momentum. So I'm going to calculate what the impulse on the ball. I should know that it would be the same as the impulse exerted on the wall, because any colliding two objects, the impulse they exert on each other is equal in magnitude, opposite in direction. So if I want to calculate the impulse on the wall, I'm just going to go ahead and calculate the impulse on the ball. And it would be the same. For each action, there is an opposite and equal reaction. All right, so they want us to calculate the impulse on the wall, so I'm going to calculate the impulse in the ball, right? It's the same thing. So first of all, this is the mass of the ball, right? And this is, so impulse equals to what? Change in momentum. For what? I'm doing it what? For the ball. They asked me for impulse on the wall, but it's equal to the impulse on the ball. both have the same magnitude of impulse, but in two opposite directions. So I, impulse on the ball, which is the same as impulse on the wall, equals to what? mv minus u. Or, if you don't like it this way, this means what? 1 second. Impulse equals to mv minus m what? mu. I can factorize m as a common factor, so it equals what? m times v minus u. Look to what I'm going to do. The mass is 0.2. The final velocity is 2.5. Just pay attention. It's 2.5 to the left. It should be what? Negative. So I'm going to do what? Negative 2.5, right? Minus what? This is to the right, so it's positive. Minus u, which is what? 3.5. So that means impulse equals to, I'm going to do the calculation, 0.2 times what? Negative 6. 0.2 times negative 6, that's 1.2. That's 1.2. So the answer is negative 1.2 what? Newton seconds. Now I shouldn't show the negative on I shouldn't show any negative signs on my final value of impulse. So what I should do, I'm going to have to write impulse equals to what? Like this. Impulse equals to what? 1.2 newtons what? Left. Just remove the negative sign. Always remove the negative sign and change it with the direction. So it will be impulse equals 1.2 Newton seconds left. Right? So don't give your final answer on the exam as negative. Give it as positive, but indicate the direction instead of negative. So say left. All right?